Okay, so now we're going to take our metadata file that we just built, and we'll be using our swiftReg batch aggregates as the template. Okay, so now we will be registering our data, and we will take our swiftReg batch standards, internal standards metadata file that we've just built, and I'll open that up so that we can take a look at this again. So for review, we've set this up so that we have our reference defined as the first batch, and it's using the internal standard. The samples that will register will be the internal standards for the other batches. And then we will finally apply the batch shift templates to the individual samples to align those as well. So to begin, we will load the metadata file in swiftReg. So that will ask us to browse to that file. And we're using the batch standards metadata file. We'll open that up. And the green highlight has moved on to registration settings, so we will click that. And we can see in the metadata file window that swiftReg batch standards metadata has been selected. Since we're doing batch registration, we'll keep this selected as batch registration. In this data file, we will also go forward with the current selection for the cluster movement modes of neighbor-dependent cluster registration plus a few rounds of independent cluster registration. Again, those details can be found in the help section for NDCR only or NDCR plus ICR. And for this demo, I'm going to reduce the concatenate size just to speed up the process when we build the files. But normally, you might want to keep this at 500,000. You might want to go 2 million. It depends on what the rarity of populations are or the frequency of various cells in those populations. So with 10,000 selected, I will choose the column that corresponds with the names of the samples. Then I'll check the reference column, and then we need to specify the samples to register. And again, all of the names specified here come from that metadata file that we just created. It asks us for the batch IDs and for the samples to shift. And then we validate. It has passed all the tests, so it selects cluster settings, and we can move on to the next section. In this section, it describes our settings for running the clustering. In this left column, we see the names of all the channels for this Cytometry data. And next to that is a column entitled DIMMs to cluster. These are the channels that would be used to build the cluster model to be used for registration. And the output medians is a way to specify the channels that you want to report data on, the medians in particular, and the arcsine scaling factors are in the next column. And the plots that we can show the effects of this transformation are here. It asks us to inspect every time. So we can look at how these arcsine transforms are being applied to the data and what is it doing before we move on to the next process. All right, so these look a little bit jagged because we're only using 10,000 cells. It would be much more smooth if you were doing a larger sample size. But these all look quite good. In Cytometry data, we generally don't have too much to worry about with the arcsine scaling factors, so we generally just select it as 1 for all of the channels. And I will discuss this in more detail in a separate video. But for now, we can just close this. And the validate channel data is highlighted, so we will select that. And because this data set is fairly small, I'm going to change this to 50. That's just to speed up the process. It doesn't have too much of an effect on the quality of the registration. And then we'll click Begin Registration. It's going to give us a window that summarizes the entire process. And so we can see that the reference sample is selected here, and it tells us in the next panel what we're doing with this sample. So it says this sample will be subsampled to 10,000 cells and used as the reference. And then it describes the samples that will be registered, and they are individuals. So the individual samples are, of course, the standards, the internal standards that will be used. And then finally, those internal standards are each going to create a batch shift template, and which we abbreviate BST. And those batch shift templates will be applied to their corresponding batches to the individual samples and move those samples in the direction to best fit that batch to the reference. And everything looks good here, so I'm going to accept this process and it will begin registering. Now the first file that it's created in our folder here is the batch standards metadata swiftReg log. And this essentially is a file that just summarizes the panel that we were just looking at. So you can go back to your experiment and find out exactly what you did, how you set it up, and which samples were run. And this will take some time. The time estimates in swiftReg are very approximate. We usually overestimate the amount of time that it'll take to run your samples. And I'm going to fast forward a bit, and we will get to the end of this quickly. And when the process is done, you'll get a message that says batch registration is complete. So we can close this and take a look at where our registered samples are. They have been added to our folder. They all have the string underscore RGST appended to the file names. And you should have the same number of registered files that you had intended to register, and that should correspond with the same number of original files. And that was batch registration using internal standards. And that was batch registration with internal standards.